Friends, all of us are familiar with these optical instruments: spectacles, microscopes, telescopes, cameras, binoculars, etc. The only common thing in them is lenses. Even our eyes have lenses, but of course they are not made of glass. So, what is the purpose of lens in all these optical instruments? We'll try to understand. The purpose of the lens is to bend the light rays to a desired extent, that is, either to converge or diverge the light rays. Now we'll try to define a lens. A lens is a homogeneous transparent medium whose both the surfaces may be curved or may have one surface curved and the other flat. The curved surfaces in the lens are for converging or diverging the light rays. Basically, we have two types of lenses: converging lens and diverging lens. As convex lenses converge the light rays, they are also called converging lens. And concave lens, they diverge the light rays, so they are also called diverging lens. The word convex means curved outward and concave means curved inward. We have three types of convex lenses: double convex lens or biconvex lens, whose both the surfaces are curved outward. We also have plano-convex lens, whose one surface is plane and the other surface is curved outward or convex. We also have concavo-convex lens, whose one surface is concave, that is curved inward, and the other surface is convex, that is curved outward. Similarly, diverging lens or concave lens are of three types: double concave lens, plano-concave lens, and convexo-concave lens. We know a lens have two surfaces, and we consider that both the surfaces of a lens have been taken out from the glass spheres. As we consider the two surfaces of the lens, this is the first surface of the convex lens, this is the second surface of the convex lens. The surface on the left side is taken as the first surface and the surface on the right side is taken as the second surface. As the two surfaces of the lens are considered to be taken out from the glass spheres, so the first surface has been taken out from this sphere and the second surface has been taken out from this sphere. Now these spheres will have the center. The center of this first sphere is C1 and the center of this second sphere is C2. So this C1 and C2 are called the center of curvature of the lens. C1 is the center of curvature of the first surface, C2 is the center of curvature of the second surface. Similarly, for concave lens also, the first surface of the concave lens is taken out from this sphere and the second surface of the concave lens is taken out from this second sphere. So here, the center of the first surface is C1 and the center of the second surface is C2. So C1 is the center of curvature of the first surface of the lens and C2 is the center of curvature of the second surface of the lens. If I mark the geometrical center on the first surface, this is called the pole of the first surface, and the geometrical center on the second surface of the lens will be called as pole of the second surface, P2. Now the geometrical center of the first surface, this is the geometrical center of the first surface of the lens, this is called the pole of the first surface. I have denoted it by P1, and the geometrical center of the second surface of the lens is called the pole of the second surface. I have denoted by P2. Let us define the center of curvature. The center of a sphere of which the surface of a lens is a part is called the center of curvature. Now we have already seen C1 is the center of curvature of the first surface of the lens and C2 is the center of curvature of the second surface of the lens. Similarly, the pole can be defined as follows. The geometrical center of the surface of the lens is called its pole. P1 is the pole of the first surface of the lens and P2 is the pole of the second surface of the lens. The radius of the first sphere from here to here, the radius of the first sphere, this is called the radius of curvature of the first surface of the lens. So we can denote it by R1, from here to here R1. So R1 here is the radius of curvature of the first surface of the lens. So R1 is P1 C1. This distance is the radius of curvature of the first surface of the lens. So if we find the distance from P2 to C2, now this distance is actually the radius of curvature for the second surface. So it is the radius of the second sphere. So we can call this distance as the radius of curvature of the second surface of the lens. So R2 is P2 C2. Again in concave lens, the radius of the first sphere, this radius of the first sphere, it is the radius of curvature of the first surface, and the radius of the second sphere is called the radius of curvature of the second surface of the lens. So here again R1, which is the radius of curvature of the first surface, is P1 C1, and R2, which is the radius of curvature of the second surface, it is written as P2 C2. The radius of the sphere from which the surface of the lens has been taken out is called the radius of curvature. The radius of the sphere of which the surface of the lens is a part, or it is the distance of the center of curvature from the pole of the lens. Now if we have this kind of lens where both the surfaces of the lens are equally convex or equally concave, then such kind of lenses are called equiconvex lens or equiconcave lens respectively. This is the diagram of equiconvex lens. In this case, the radius of curvature of the first surface, the distance from P1 C1, which is R1, and the radius of curvature of second surface, the distance of C2 from P2, this is R2. If they are equal, R1 and R2 are equal, this value and this value are equal, then in this case this lens will be called as equiconvex lens. If we join these two centers C1 and C2 by a straight line like this and extend this line beyond this point C1 and C2, then this straight line passing through the centers of curvature of the two surfaces and extended on both the sides, this line, straight line, is called the principal axis of the lens. Similarly, here if we join the two centers of curvature by a straight line and extend this line beyond C1 and C2, so this straight line will be called as principal axis in case of concave lens. The straight line joining the two centers of curvature and extended on both the sides is called the principal axis. The next term related to the lens is the optical center. For a thin lens, the optical center is a point on the principal axis of the lens such that the rays of light passing through it passes undeviated. As the lens have two surfaces available for refraction, therefore a lens will have two focal points or two foci, first focus and the second focus. Let us discuss the first focus. First focus of a lens is a point on the principal axis. is a point on the principal axis. So in case of a convex lens, if the rays of light are diverging from it, then after refraction from the lens, they become parallel to the principal axis. But in case of a concave lens, the rays of light which are appearing to meet at the first focus, after refraction from the lens, they become parallel to the principal axis. So here in this case, if you see, I have drawn this vertical line here and here. So we are showing the refraction or bending of light taking place from this line. This line is actually used in order to have clarity in the diagram. So this line is called the aperture of the lens. First focus is a point on the principal axis of a lens such that the rays of light diverging from it in case of convex lens or appearing to meet at it in case of concave lens after refraction becomes parallel to the principal axis. Now let us learn about the second focus of the lens. Second focus of the lens is also called principal focus. If we simply say focus of the lens, then we mean the second focus. In case of a convex lens, second focus is a point on the principal axis so that the rays of light, incident light, parallel to the principal axis, after refraction from the lens actually meet at this point. Then this point is called the second focus or the principal focus of the convex lens. In case of a concave lens, as it is a diverging lens, if the rays of light parallel to the principal axis, after refraction, it goes like this, it goes like this. After refraction, if they appear to come from this point, if they are produced backward, they appear to meet here. If they appear to come from this point, then this point on the principal axis will be called as second focus of the concave lens. So, the second focus or principal focus is a point on the principal axis of a lens such that the incident rays of light parallel to the principal axis after refraction actually meet at it in case of convex lens or appears to diverge from it in case of concave lens. If we measure the distance of the focus from the optical center of the lens, then this distance will be called as the focal length of the lens. So focal length of this convex lens is from here to here, from O to F, optical center to the focus. This focal length is denoted by small letter f. In this case, in case of concave lens, the distance of the focus from the optical center of the lens, this distance if we measure, then this distance will be called as focal length of the concave lens. So, the distance of the focus from the optical center of the lens is called its focal length. Its SI unit is meter. If we consider a plane surface like this, a plane which contains the focus, and if this plane is perpendicular to the principal axis, then this plane will be called as focal plane. So focal plane is defined as a plane that contains the focus and it is perpendicular to the principal axis. When we see a thick spectacle lens, then we know it has more power because it bends the light more. Power of a lens is the measure of its ability to bend or refract the light. Thick lenses bends the light more than the thin lenses. Therefore, thick lenses are more powerful than the thin lenses. Power of the lens may also be defined as the reciprocal of its focal length. So power P is 1 by focal length if the focal length is measured in meter, and power P is equals to 100 by focal length if the focal length is expressed in centimeter. The unit of power of lens is diopter.